In this video, we're going to talk about geometric sequence and series. In the previous video, we talked about arithmetic sequence and series. If you haven't checked out that video, make sure you check out that first, because this will be not necessarily a continuation of that, but there will be a question at the end of this video that combines both arithmetic sequence and geometric sequence. Overall, we have already talked about what a sequence is. I will not repeat myself too much. Sequence is numbers that are listed back to back and they follow a certain pattern. Now in arithmetic sequence, we mentioned that you get the next value by adding or subtracting to the previous value. But in geometric sequence, again, there should be a pattern, but here we get the next value either multiplying or dividing by something. So here's what I mean. 2, 4, 8, 16, ... Assume this is an infinite series. Now, infinite geometric series. So how do we get the next value? How do we go from 2 to 4? Now, it seems like we can add 2, right? Which is fine. We can say, okay, we're adding 2. But then it should follow the same pattern, right? So then that means if I add 2 to 4, I should get 8, which I don't. So what's happening here is we're actually not adding 2, we're but multiplying by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, etc., etc. So our difference, we call that difference in arithmetic sequence, and used D as a letter to show the difference. But here we're going to show it with R. So R here is going to be equal to 2, meaning we get the next value by multiplying the previous one by 2. Now, sometimes this is an increasing sequence. We can also have a decreasing one. For example, 16, 8, 4, 2. Now, what am I doing here? I'm multiplying or dividing by 2 or multiplying by 1 over 2. Same idea. 1 over 2 to get to the next value. So my R here is going to be 1 over 2. This one is a decreasing one. All right? So, again, same as in arithmetic sequence, the question is, how am I going to find the nth term? So if the question says, find me the 100th term of this sequence, which will be a very large number actually, let's say 10. I could manually write it down, but manually is not what we're looking for. We're trying to use some formulas that we have, because the numbers will be large usually, so you won't have enough time to manually write them down and find the value that you're looking for. Okay? And plus, it's much easier with the formula. So the nth term of a sequence, we're looking at this formula right here, is equal to un, meaning nth term, is equal to u1. You already know what u1 is from arithmetic sequence. u1 means the first term, multiplied by r to the power of n minus 1. R meaning the difference. Right? So there's nothing unclear here, I hope. u1 is the first term, r is the difference, and n is just n, the nth term. So let's test something out. For example, u10. u10 is going to be equal to u1, which is 2, times r is, I'm looking at the first sequence here, 2, 4, 8, 16. R is 2, and n minus 1 is going to be 10 minus 1. So the answer is going to be 2 times 2 to the power of 9, which from exponents, hopefully you know, we're going to review them later, but when the bases are same, we just add the top. So it's going to be 2 to the power of 10. And if I remember it correctly, that's going to be 1024. So the nth term of this geometric sequence is going to be 1024. So the next thing we're going to look at is the sum formula. Okay? If you remember from arithmetic sequence, we also had a sum formula, right? This is basically the same structure, but the formulas are different because the pattern is a bit different. Now, how do we get the nth term? We have, I'm just going through the formula here. By the way, these formulas are from formula booklet, so make sure you're always working with formula booklet just so your eyes get used to where things are, and in the exam you're not looking for something. You exactly know what is there and what's not there, and maybe there could be things that you have to memorize besides the formula booklet, so you're not too dependent on it. Okay? So Sn is equal to u1, again, first term, multiply r to the power of n minus 1 divided by r minus 1, or same as arithmetic sequence, there is another formula here, 1 minus rn, 1 divided by r. They're basically same thing, but switched places, and because both of them are switched, both the numerator and denominator, it's fine. Okay? And r obviously has to be different than 1, because otherwise the denominator will become 0, which we're trying to avoid at all costs. So let's find S10 and practice our formula. So S10 is going to be u1, which is 2, times r is also 2. Let me put a bracket here as well. To the power of n, which is 10, minus 1, divided by r minus 1, which is 2 minus 1. So denominator becomes nice and easy, just 1. At the top we have 2 times 2 to the power of 10 minus 1, which we already know what 2 to the power of 10 is, 1024. Minus 1 is going to be 1023. So the answer is going to be 2046, I believe. 1023 times 2. Okay? Now, there is one more thing in geometric sequence which we haven't talked in arithmetic sequence because it doesn't exist, is the sum of infinite geometric sequence. The sum of an infinite geometric sequence. And that's equal to, you can see the S infinity is equal to u1, 1 minus r. The key here is, though, it's not applied to any geometric sequence. It's only applied to the one where r, or absolute value of r, rather, is less than 1. So basically values that are less than 1. Or less than negative 1. That's why there's an absolute value. Meaning, if your numbers so the first sequence that we have, 2, 4, 6, 2, 4, 8, 16, has r value of 2, so it won't be qualified for this. But the second one, where r is 1 over 2, will be qualified. Now, a little side note, I hope you're asking this as well, is how come the first one, we don't do it for the first one, but we do it for the second one? And the answer to that question is, because the first one will increase infinitely, or diverges, if you will, so there's no end to it. That's why there is no formula. It will go to infinity. But the same goes for arithmetic sequence, by the way. If you keep adding or subtracting something, it will eventually either go to positive infinity or negative infinity. But when we have a value less than 1, like 1 over 2, this will eventually get closer to a certain value. For example, 16, 8, 4, 2, next value will be, let me write it here, then 1, then 1 over 2, right? Then 1 over 4, then 1 over 16. Now, it will never become, it has a limit, basically. Now, this is more like an asymptotic thing, but since we haven't covered them yet, I will not go any deeper. Just try to understand that when you have a fractional r, this value will not pass a certain limit. Will not pass a certain limit. For example, this specific one will never become negative. It will get very close to the 0, but it will never become 0 as well, but it will get infinitely close to 0, right? Anywho, so we have a formula. Let's go back to that. S infinity equal to u1, 1 minus r. So let's try. Let's try the S infinity for the second sequence here, which is 16, 8, 4, 2, the one that's decreasing. So S infinity is going to be equal to u1, which is 2, 1 minus 1 over 2. And that's going to be 2 divided by negative, not negative, just 1 over 2. And that's going to be equal to 4. So sum of this infinity will be getting will be 4. Okay, so you'll see some questions where we have to find the infinite sum, and when do we do it? Usually when the question actually asks or tells us that we have infinite geometric sequence, or find the sum of infinite geometric sequence. So to sum it up, we have 3 parts: un, nth term geometric sequence; Sn, sum of n terms of a finite geometric sequence; and the sum of infinite geometric sequence with the last one we just looked. All right, with that being said, that's going to conclude our theory section, and let's move on to some examples. The 5th term of U5 of a geometric sequence is 125. The 6th term is U6, which is 156.25. Find the common ratio. So common ratio is R. We're looking for R here. All right. So let's check it out. U5 is equal to 125. I like to write things, whatever is given in the equation, or the question rather. U6 is equal to 156.25. Now, the great thing here is they are back to back. So in arithmetic sequence, if you remember, we said that to find a difference, we subtract the next one, or we subtract the current one from the next one. So next minus previous. In here, it's the same thing, but with division. So R is going to be equal to U6, this is the next term, divided by previous, which is U5. So 156.25 divided by 125. And that is 125. So the common ratio is 125. Find U1, the first term of the sequence. Now that we know R, we can use either U5 or U6. It doesn't matter. I'm going to go with U5 because it seems to have a nicer number. So what is U5? U5 is equal to 125. But we also know from the formula, if you check out the formula on the top right corner here, should be equal to U1 times R to the power of n minus 1. Now, do we know our U1? We don't. That's what we're looking for. So I'm going to leave the U1. Do we know our R? Yes, we do. 1.25. N is 5 because we're looking for U5. So n minus 1 will be 4. Okay, so what do we have here? What equation do we have? We have 125 equals to U1 times 125 to the power of 4. And from here we can find U1 by subtracting 125 by 1.25 to the power of 4, and that's going to give us 52 or 51.2. 51.2. So that's U5. Calculate the sum of first 12 terms of the sequence. So S12 is what we are after. All right. Now, what is the formula? Again, U1, which we just found, 51.2. Then multiplied 1.25 to the power of n, which is 12, minus 1 divided by r minus 1. What's our r? 125 minus 1. So at the bottom, we're going to have 0.25. And at the top, we're going to have, I don't know, some value, and which is, I don't want to use a calculator now, but you can do it on your own, some value, and that's going to be equal to 2775. Just looking at the answers. Okay, but the idea is the same. Use the formula. U1 is what we need for S12, and R is what we need for S12. First 3 terms of a geometric sequence is U1 32, U2 is negative 16, and U3 is 8. Find the value of common ratio R. Now, whenever, generally speaking, U1 is given, you know that your life will be much easier because U1 is used in every formula. But even if it's not given, then you have to do a bit of extra work to find it. But here we have u1, u2, u3, which means we can find our common ratio. Again, common ratio is going to be equal to either u2 divided by u1 or u3 divided by u2. So it doesn't matter, both should give us the same answer. So negative 16 divided by 32, and that's going to be negative 1 over 2. So you notice that we have a value which is less than 1. R is less than 1. How is that relevant? Because of this formula. You know that we're now dealing with R that's less than 1. So there could be a case of infinite sequence, which there is if you look at C. But let's do B first. U6, find U6. U6 is equal to, what do we know already? We know that U1 is 32. So I'm going to write that. I'm using the formula, by the way, times R. My R is negative 1 over 2 to the power of n minus 1. So 6 minus 1. So 32 times negative 1 over 2 to the power of 5. And if you know your exponents, you will know that this is going to be, well, this will stay 32. 32 times 1, negative 1, because the power is odd value. And at the bottom, 2 to the power of 5. Okay, we can further simplify that. 32 times negative 1, this is also 32, so it's going to be negative 1. It's going to be negative 1. Cool? So we found U6, negative 1. Now, negative 1. Now, last one, S infinity. S infinity, again, we have a formula, U1 divided by 1 minus R. Assuming R is, absolute value of R is less than 1, which we have. The absolute value of our R is 1 over 2, so it qualifies for the condition. U1 is 32, 1 minus negative 1 over 2, 32, and here we have 2, 3, so 3 over 2, and if we take it a step further, that's going to be 32 times 2, which is 64, divided by 3. So the answer to the last one is going to be 64 divided by 3. All right, last question here. I like this question because it combines both geometric and arithmetic sequence. So let's see what we can do here. The first term of an arithmetic sequence is 24 and the common ratio is 16. Okay, so let's call it for our arithmetic sequence, U1 is equal to 24, and D, remember in arithmetic sequence we use D, not R, is equal to 16. Find the value of 62, the term number 62 of the sequence. So we're looking for U62. So as you see from the formula, for U62 we need U1 plus n minus 1 times D. U1 is given 24 plus n is 62, so that's going to be 61 times 16. So that should be a very large number, which I believe comes to 1,000. Okay, that's A. 1,000. Now, the first term of a geometric sequence is, now we're talking about geometric. So first term, U1, is equal to 8. And the fourth term of the geometric sequence is equal to 13th term of the arithmetic sequence given above. So this is the key sentence here, right? We have to use both of them. So U4, they're saying U4 of arithmetic is, U4 of geometric is equal to U13 of arithmetic. Okay, now what is u? Do I have a space here? Yes, I do. Maybe not actually. Let's see. So u4 in geometric is what? u1. Let me write it. u4 is equal to u1 times r cube. Yes? What's our u1? 8. So 8r cube. That's our u4 in geometric. u13 on arithmetic is going to be equal to what? u1, which is 24, plus n minus 1 times d. So n minus 1 is going to be 12 times d. What's our d? Is 16. And that's going to be 216. So again, the claim says u4 has to be equal to u13, meaning 8r cube has to be equal to 216. So B says write down an equation using that information. So that's exactly what we're going to write. 8r cube is equal to 216. Last part, C. Calculate the common ratio of the geometric sequence. C. Let me write, this is B and this one was A. So calculate the common ratio of the geometric sequence, meaning we're looking for an r. So I'm going to use the equation from B. 8r cube equals to 216. From here we can say r cube is equal to 216 divided by 2, which I think is going to be 27. And from here we can find r by cubic rooting both sides, and that's going to be equal to 3. So the common ratio of this geometric sequence is going to be equal to 3. So that's all for the geometric sequence. We did 3 examples. There's timestamps under the video. Make sure you check them out. And if you can pause the videos before I do the solution, that would be great, so you can practice on your own as well. If you haven't checked out the arithmetic sequence video, make sure you do that. And the next video is going to be about problem set, both for arithmetic and geometric sequence, and most of them will be about the word problems, reading the description, understanding how we can turn that into either geometric sequence or an arithmetic sequence. And that's all for now. Hopefully you learned something. If you find it useful, make sure you like and subscribe or share with someone that you might think it will be useful for. If you have any suggestions, I would love to hear them. Please do mention them in the comments. Other than that, that's all I got for you today. I will see you in the next one. Bye-bye.